Hello everyone. So this is our second lecture of first order differential equation. In my first lecture, what we have learned? First topic is what is differential equation. Second topic was what is ordinary differential equation and what is partial differential equation. Third topic, that was what is the order and degree of a differential equation. And fourth topic, that was no degree part. Okay, and in your syllabus in module 1 the topic is first order ordinary differential equation. Okay, this is the topic of module 1. Now, first order ordinary differential equation. You know what is first order? That means the derivative, highest order derivative in this equation will be 1. Okay. Now, first order differential equation, that will be two types. First will be first order and first degree. Okay, first order and first degree. And second type will be first order and higher degree. Okay, and today's topic is first order and first degree. Clear? Okay, so we have completed all these topics in our previous lecture, and in this lecture, that means lecture number 2, we will learn the topic first order and first degree. Clear? So let's start. Topic is first order and first degree. Okay, so since I am saying that first order, okay, and first degree, so in this differential equation the order will be 1. Yes or no? First order 1, that means you will have dy dx. Okay, also it is given first degree, that means the power of highest order, that means this dy dx, that will be 1. Yes or no? So you can write dy dx, this is equals to, let's say dy dx plus y, this is equals to x. Let's say I am taking an arbitrary example. Is this equation first order and first degree? Obviously yes, because we have dy dx, this is first order, and the power of dy dx is 1, so this is first degree. So this is first order and first degree equation. Now we have to form the general form of first order first degree equation. Okay, so let's understand using this example. Dy dx plus y, this is equals to x. Actually we can write this equation in this form, that dy plus y dx, this is equals to x dx. Yes or no? We can write in this form. So or you can write y minus x dx plus dy, this is equals to 0. Yes, we can write in this form. So this differential equation, I have changed this differential equation into this form. Let's say this form is of the form m dx plus n dy, this is equals to 0. Now if you compare these two equations, tell me what is m? M is equals to y minus x, and what is n? N is equals to 1. So obviously any first order first degree differential equation, we can convert any first order first degree differential equation in this form. Clear? Where what is m? M is a function of x and y. Similarly n is a function of x and y. Okay, so m is a function of x and y, or maybe it is constant, and similarly n is a function of x and y. Clear? So in this equation m is equals to y minus x and n is equals to 1. Clear? So we can see that any first order first degree differential equation can be written in this form m dx plus n dy equals to 0. That's why this is called the general form general form of first order first degree equation. Clear? Now this equation will be called exact equation. This is your next topic. Next topic is exact equation. And let me tell you, this is very, very important. Exact equation, very, very important. So this equation, first order first degree equation, this equation will be called exact equation depending on some conditions. So first understand using an example, then we will discuss what is exact equation. Okay, suppose I am giving you an example or an equation. Let's say x dy plus y dx, this is equals to 0. So this is of the form m dx plus n dy, this is equals to 0, yes or no? So obviously this equation is first order first degree equation. Okay, okay, okay. So y dx, we can write y dx plus x dy, this is equals to 0. Can you tell me this left hand side, this is a derivative portion of a special function. Can you tell me the function? Y dx plus x dy, this is the expression or derivable expression of a function. And what is the function? Xy na? So we can write this is equals to d of xy, this is equals to 0, yes or no? That means here the left hand side, this left hand side, we can write the left hand side in an expression, that in a derivative expression of a function. Okay, so y dx plus x dy, we can write this expression as a derivable function of xy. Okay, so in general, if we can write an equation m dx plus n dy, okay, this is we can express this form m dx plus n dy equals to 0 as a derivative of a function. We can express the left hand side of the equation m dx plus n dy as a derivative of a function, then this equation m dx plus n dy equals to 0 will be called an exact equation. Let me write the definition. So a differential equation, of first order and first degree can be expressed in the form m dx plus n dy equals to 0, where m and n are functions of x and y. Okay, if there exists a function u is a function of x comma y, such that the expression, we can write this expression m dx plus n dy, this is derivative of a function u. Okay, so we can write m dx plus n dy, this is equals to d of u. Okay, so if we can write any differential equation as a derivative of a function, then that differential equation m dx plus n dy equals to 0 will be called an exact equation. Okay, actually this is the definition of exact equation, but you can see that you can find out the function u if the equation is an easy equation, but if the equation is any hard equation, then you cannot find this function u. Yes or no? For example, let's say I am giving you x dy minus y dx, this is equals to 0. Can you find out the function u? You cannot find out the function u because this equation is not exact equation. That means here we have a problem in this definition. What is the problem? That the problem is we cannot find out the function u easily. That's why we have another approach. And what is the approach? So next topic, a condition of exactness. Condition of exactness. Okay, now how you can identify that a differential equation is exact or not? The statement is the necessary and sufficient condition, the necessary and sufficient condition that m dx plus n dy equals to 0 be an exact equation if actually the equation is m dx plus n dy equals to 0. And what is m? M is a function of x and y, and similarly n is a function of x and y. So obviously if m is a function of x and y, so obviously you can calculate del m del y. Del m del y means partial derivative of m with respect to y. Okay, and similarly you can calculate del n del x, that means partial derivative of n with respect to x. Now if these two derivatives del m del y and del n del x, if these two derivatives are equal, then the equation m dx plus n dy equals to 0 will be called exact equation. Okay, and this condition is necessary and sufficient condition. Necessary and sufficient means if it is given that the equation is exact equation, obviously you can say that this condition will hold. Okay, or conversely, if the condition is given, obviously you can say that the equation will be exact equation. Okay, that means this is both side true. Okay, this is imply and implied by statement. Clear? So for an equation, for an ordinary differential equation, the condition of exactness is del m del y equals to del n del x. Clear? Now it is very easy. We need not to find out the function u. Yes or no? Let's try an example. Question is the equation e to the power x sin y dx plus e to the power x plus 1 cos y dy, this is equals to 0, an exact equation? This is your question. You have to check this equation is exact or not. Actually if I compare with the general form, that means m dx plus n dy equals to 0. If I compare with this equation, so what is m? M equals to, m means coefficient of dx and n means coefficient of dy. So coefficient of dx is e to the power x sin y. So this will be e to the power x sin y. And similarly, what is n? N is equals to e to the power x plus 1 into cos of y. Okay. Now according to the given condition, according to the condition of exactness, you have to find out del m del y. So this is equals to del m del y, that means partial derivative with respect to y. And partial derivative, when you are deriving with respect to y, then all other variables will be considered as constant. Okay, so del m del y, so derivative with respect to y. So here it is given sin y, and derivative of sin y is cos y. So this will be e to the power x cos of y. Similarly, del n del x, derivative with respect to x. So this will be e to the power x into cos of y. Clear? Actually, we can break this in this formula, e to the power x cos y plus cos y, and derivative with respect to x. So with respect to x, so there is no function of x, so this will be 0, and this will be derivative of e to the power x is e to the power x, and cos y is constant, so this will be e to the power x cos y. Obviously, you can see that del m del y and del n del x both are equal. So here del m del y, this is equals to del n del x, and this imply the equation is exact. Clear? The equation is exact. Let's try another problem. The equation is y square e to the power xy square plus 4x cube dx plus 2xy e to the power xy square minus 3y square dx. Okay, first one is dy. This is equals to 0. Let's solve this one. You have to check the exactness. Okay, so solution. If you compare with the general form, here you can see that the dx coefficient, this is not in the form of m dx plus n dy. This is of the form n dy plus m dx. Yes or no? So what will be m? This will be your m. Okay, so m is equals to 2xy. M means coefficient of dx and n means coefficient of dy. Bas. So m is equals to 2xy into e to the power xy square minus 3y square. And what is n? N is equals to y square e to the power xy square plus 4x cube. Clear? So you have to calculate del m del y. This is equals to, first this portion, this will be uv formula. Okay, so first 2xy derivative with respect to y, so this will be 2x into e to the power xy square. Okay, plus, now second will be e to the power derivative of e to the power xy square, so this will be 2xy into derivative of e to the power x, this is e to the power same e to the power xy square into derivative with respect to y, so this will be 2xy. Okay, so we are getting 2x e to the power xy square plus 4x square y square e to the power xy square. Okay, and derivative with respect to y, so this will be minus 6y minus 6y. Okay, now let's write n is equals to y square e to the power xy square plus 4x cube. So del n del x, this is equals to, okay, so with respect to x, so this will be y square into e to the power xy square into with respect to x, so if you derive xy square, so this will be y square. Okay, plus this is 12x square, so you are getting y to the power 4 e to the power xy square plus 12x square. So obviously you can see that in this equation del m del y is not equals to del n del x. Yes or no? Del m del y is not equals to del n del x. So this equation is not exact equation. Clear? This equation is not exact equation. But problem is, in question paper they will not ask you the exactness. Just they will tell you that solve the equation. So obviously we have to understand how to solve an exact equation, and we will discuss the solution of exact equation in my next lecture. Okay, I think the concept of exact equation is very clear. If you have any doubt, then you can ask me in my WhatsApp group. I have created a WhatsApp group only for my YouTube students, and you will be given the link of WhatsApp group in my description, this in the description of this video. Okay, so go to the description and join this WhatsApp group. Thank you so much.